All right, so finding the equation of the line in point slope. So we have y minus y1 equals m times x minus x1. x1 is -5, and y1 is 2. But m that we're going to use, it needs to be perpendicular, or a slope that's perpendicular. And so this line would have, if we divide by -4 now, this line would have a slope of 3/4. So we use a slope negative reciprocal. When you have perpendicular lines, take the reciprocal and change the sign. So we have -4/3. So that's x plus 5. And that's point slope. So according to the directions, we can leave it just like that, point slope. However, the next one says parallel to this line and then write in slope-intercept form. So remember, parallel means same slope. Whereas perpendicular means opposite or negative reciprocal. And so if I've got the line 2x minus 3y equals 5, I subtract 2x from both sides and then divide by -3. So therefore, we use the point 2, -3, and we use a slope that's the same 2/3. So we go y minus y1 equals m times x minus x1. Writing in slope-intercept form, we need to distribute the 2/3 across and then subtract 3. -4/3 minus 3, it's over 1, so that's -4/3 minus 9/3, which is -13/3. Number 8 passes through this point, and it's perpendicular to the line x equal to 5. So if the line x equal to 5 is a vertical line, and we want it to be perpendicular to that, but pass through 1/3 -3, then our line is vertical. Vertical passing through that point, but remember, vertical lines come from the mnemonic device VUX, which means it's x equals 1/3, the x value on that. But if the problem had said be parallel to the line x equal to 5, oh, I just messed that up, didn't I? Sure did. We want it to be perpendicular to the line x equal to 5. Our line is going to be horizontal, so it needs to be y equals. And the mnemonic for horizontal lines is OI, or y equals the y value, which is -3. Now, if we would ask for it to be parallel to line x equal to 5, we would have used x equal 1/3. Graphing 3x minus 4y equals 12 by using the x and y intercepts. And that's kind of two ways about going about doing this. And one of the ways is the more standard approach, which we normally write it in slope-intercept form first. So the y-intercept is the b on there, which is 0, -3. And then we have a slope, which is 3/4, rise 3 and run 4, 1, 2, 3, and run 1, 2, 3, 4. And so it looks like our x-intercept must be 4, 0. But then we continue on and rise another 3 and run another 4. So we can't go any further. Down 3 and left 4. It's appearing that I counted incorrectly when I did these points. So I'm rising 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Okay, the other way to find the x and y intercepts is what we would call the cover-up. The x-intercept, we set y equal to 0, so we cover up the y, and we get 3x equals 12, or x is equal to 4. The y-intercept, we set x equal to 0, cover that piece up, and you have -4y equals 12, or y equals -3, giving us 0, -3. So it's kind of nice to do both of those for a double check. Now if we graph this line using the slope and y-intercept, we see the y-intercept is 0, -4, and the slope is 5/2. So we start down here at 0, 1, 2, 3, 4, and then we rise 1, 2, 3, 4, 5, and run 2. Rise 1, 2, 3, 4, 5, and run 1, 2. 1, 2, 3, 4, 5, and run 2. Or drop 5, 1, 2, 3, 4, 5, and run 2. And there's our points. This time we tell you the x-intercept is -2. What that means is it's -2, 0. So we go over the x-axis at -2. And then we rise -3, or go down 1, 2, 3, and then run 1, 2, 3, 4. Rise -3, 2, 3, and run 1, 2, 3, 4. Rise another 1, 2, 3, and run 1, 2, 3, 4. Or if we put the negative on the bottom one, then we would rise 3, 1, 2, 3, and run left 1, 2, 3, 4. And there's our negative slope going down. Number 12, state the slope, x-intercept, and y-intercept of -x plus 4y equals 4. I like to play that cover-up game first. If I set x equal to 0, I have 4y equals 4, or y equals 1. So that's 0, 1 for the y-intercept. If I set y equal to 0, then I have -x is 4, x is -4. That's -4, 0, which is the x-intercept. Easiest way to come up with a slope then is to write in slope-intercept form, add x to both sides, and now divide by 4. So we go to the y-intercept of 0, 1, and then we rise 1 and run 1, 2, 3, 4. Rise 1 and 1, 2, 3, 4. Or we drop 1 and go left 1, 2, 3, 4. Drop 1 and go left 1, 2, 3, 4. Drop 1, left 1, 2, 3, 4. So it said to state the slope, so we'll state it as m is equal to 1/4. All right, all those points lie on the same line, so I know I'm pretty good there. So one more reminder of OI and VUX. In this example, x minus 3 equals 4. We add 3 to both sides, and we get x equals 7. If you go to the first spot where you see x is 7, 1, 2, 3, 4, 5, 6, 7, all of these points up and down from there are going to be where x is 7. So we have this vertical line through x equals 7. It's not going to have a y-intercept, but the x-intercept is going to be 7, 0. If you have y plus 4 equals 0, then now we're looking at an OI. Horizontal lines have 0 slope and have the equation y equals a number. So if I go down to y equals -4, and so we have a horizontal line, it will have no x-intercept, but it'll have a y-intercept of 0, -4. All right, so that was graphing our lines. The cost to rent a car for a day is $53 plus 62 cents for each mile driven. The total cost C is given by the equation. C equals 53 plus 0.62x. 53 is the fixed cost per day, and then each mile is 62 cents. So we have to multiply that by the number of miles to get the total cost. So if you drive the car for 50 miles, you're going to take the $53 and you're going to take 62 cents times 50. 50 times 62 is 31 bucks, and so that gives us $84 to drive the car 50 miles. But if you only have $75.32 to spend to rent this car for a day, then it's $75.32 equals 53 plus 62 cents times x. Subtracting 53, 22.32 equals 62 cents. X is 22.32 divided by 62. So that's 62 into 22.32. So 36 miles will keep that cost at $75.32. Okay, now perform the given operation. Write your answer in simplified form and with positive exponents. 3x minus 7 squared. We did this a lot in the class. 3x minus 7 times 3x minus 7. So we FOIL that out and get 9x squared minus 21x minus another 21x plus 49. So the like terms in the middle, minus 42x plus 49. Number 17, we have some negative exponents there. I'm going to deal with the negative exponents in the first fraction. Inside, I should say. X to the negative 3 goes up the top next to that x squared. So that's x squared times x cubed. The y to the negative 1 goes up top next to that y cubed, and the 2 stays down in the bottom. Now, x squared x cubed is x5, y third y first is y4, negative 2 as an exponent. The negative exponent on the first fraction is going to flip everything. 2 goes top, x to the 5th, y to the 4th, squared, x to the 6th, y to the 7th, over 2. Now we square everything inside. Negative 2 squared is 4. X to the 5th squared is x to the 10. Y to the 4th squared is y to the 8th, times x to the 6th, y to the 7th, over 2. 2 goes into 1 into 4 twice. X to the 6th over x to the 10th. There's more x's on the bottom. In fact, there's 4 more. So that's x to the 4th. Y to the 8th under y to the 7th. There's 1 more y. And so we're left with 2 over x to the 4th y. Okay. Number 18, squaring negative 3, that becomes 9, and squaring x becomes x squared. Negative 2 to the 4th is positive 16, x to the 4th. 1/3 squared is 1/9, x to the 4th squared is x to the 8. 9 times 16 is, well, let's do this. 9 on the bottom, 9 on the top, and then I won't have to multiply anything. 16 x to the 2 plus 4 is 6, plus 8 is 14. 16x to the 14th. Okay. Here we have negative 2/3 multiplied by negative 24 over 1. We have an s squared and an s to the 4th. And we have a t to the 7th and a t. Now 3 goes into 3 once, and into 24, 8. Negative 2 times negative 8 is 16. S squared s to the 4th is s to the 6th. And t to the 7th times t is t to the 8. Number 20, we take negative 2 to the 4th power. A cubed to the 4th power is a to the 12, and b to the 4th. Negative 2 to the 4th is 16. Six x y to the 0. Well, the 6x is by itself. The y is to the 0, and that's 1. So we're just left with 6x. 22. 4 goes into 4 once, into 12 3 times. And now we'll start moving negative exponents. The b to the 1st is not to a negative, so it stays there. But the b to the negative 3 on the bottom goes up top as b cubed. A to the negative 6 on top goes down as a6. A to the negative 1 on bottom goes to top as a. So now we have a over a to the 6th, which is a to the 5th. b times b cubed is b to the 4. '23 is an easy one. Anything to the 0 power is just 1. That 0 is on the outside of everything in there. 24, 3 to the negative 1 is 1/3. 5 to the negative 2 is 1 over 5 squared. That's 1/3 plus 1/25. LCD is 75. So that's a 25 top and bottom to get 75, and that's a 3 top and bottom to get 75. So we have 25 plus 3, which is 28 over 75. '25. The a to the negative 2 will go to the bottom as an a squared, and the b to the negative 6 will go to the top as b to the 6th, plus negative 2 times negative 3 is b to the 6th. Negative 2 times negative 1 is positive 2. It's a to the 2nd. But that 2 raised to the negative 2 power makes it go up top as 2 squared, or 4. And so what we have there now is two like terms. They both have the same variable part. 2 plus 4 is 6. B to the 6th over a squared. All right, a to the 9th, a to the negative 8. 9 minus 8 is 1. It's a to the 1st. A to the 0 is 1, and the a to the negative 5 goes to the top as a to the 5th. So that's a to the 6th power. '27. Distribute the 3y. That gives us 12y cubed. 3y times 5y is 15y squared. 3y times negative 3 is negative 9y. Negative 4y squared. Negative 5y. And positive 3. Foil that. That's 49y to the 4th. 28y squared. Minus 28y squared and minus 16. Collecting the like terms in the middle, they cancel each other out. We're left with 49y to the 4th minus 16. '29. We've got 3x minus 5 squared minus whatever the result of 2x minus 3 times 2x plus 3 is. Remember, subtraction comes after multiplication. 3x minus 5 times 3x minus 5 is 9x squared minus 15x, which is minus 30x plus 25. 2x minus 3 times 2x plus 3 is 4x squared minus 9. The middle terms cancel out on those. So we have 9x squared minus 30x plus 25 minus 4x squared plus 9. Like terms, 9x squared minus 4x squared is 5x squared minus 30x plus 34. Number 30. Plus sign doesn't change anything, but the minus sign distributes. All right, got some like terms there. Negative 4w squared plus 2w squared is negative 2. Minus 5 is negative 7w squared. 6w plus 7w is 13w. And 1 minus 5 is negative 4. Minus signs distribute across and change the signs. A plus and now a minus. 4x squared y minus 5x squared y is negative 1x squared y. (10x plus 2x is 12x. And then that xy squared isn't like anything, so we attach that minus 3xy squared. All right, then we got into division by monomial, where we distribute the 7y cubed to each term. 28y cubed over 7y cubed is 4. 14y squared over 7y cubed is 2, but there's more y's on the bottom now, so the leftovers go to the bottom. And 21 over 7 is 3. Y over y cubed is y squared. Plus 49 over 7 is 7 over y cubed. Same problem, some kind of problem. 16m cubed divided by 8m squared plus 8m squared divided by 8m squared minus 4 over 8m squared. 8 goes into 16 twice. M cubed over m squared is m. 8's cancel, m squareds cancel, just left with 1. 4 goes into 8, 2. And the m squared left over. 1 over 2m squared. Okay, then you're going to have long division on this test. Guaranteed to see a long division problem. The divisor is x minus 2, and I'm going to divide that into x cubed. There's missing the x squared term, so I'm going to put a placeholder in there, put a 0 for it, plus 4x minus 3. X cubed over x is x squared. X squared times x is x cubed minus 2x squared. We subtract by changing the signs, and those cancel. 0 plus 2 is 2x squared. And we bring down the 4x now. And now we start over again. 2x squared divided by x is 2x. So that's the next term. And then we distribute 2x times x is 2x squared minus 4x. We change the signs. 4x plus 4x is 8x. Bring down the 3. Start over again. 8x divided by x is 8. And so we put an 8 up here. 8 times x is 8x, and 8 times negative 2 is negative 16. Subtract by changing the signs. Positive 16 minus 3 is 13. So we write quotient plus remainder over the divisor. Another problem to practice for long division. 3x plus 5 into 12x squared plus 14x minus 10. We start by dividing first. 12x squared divided by 3x, which gives us 4x. So the 4x goes above. 4x times 3x is 12x squared, and 4x times 5 is 20x. We subtract by changing the signs, and 12 minus 12 is 0. 14 minus 20 is negative 6. We have negative 6x divided by 3, which is negative 2. That's the last term. Negative 2 times 3 is negative 6x. Negative 2 times 5 is negative 10. We subtract by changing the signs, and this gives us 0. So our answer is just 4x minus 2 with no remainder. That tells us that 4x minus 2 and 3x plus 5 are the factors of 12x squared plus 14x minus 10. I'll just tell you that there's no scientific notation on the final. It'll save you about 5 minutes. You won't have to study that. All right, let's see if we can get through these factoring problems. There's quite a few on here, and then we'll call it for tonight and then work again on the final review tomorrow night. So as you see here, the top of the final, I will give you the cubes formulas. You won't have to memorize those. Those will be given to you on the test. X squared minus 3x minus 108. We're looking for two numbers whose product is negative 108 that adds to negative 3. And 108, it's kind of a big number there. I feel like it's, I know 9 goes in there. Let's see. Yeah, 9 and 12. But I need the negative on the 12. And so when the coefficient of x squared is 1, you find those numbers and you're done. Don't have to do anything else with it. When you do something like 45, though, with an 18 in front of there, we do the same game of 180 to get negative 63. And so negative 60 and negative 3 are those numbers. But this time you have to put them back in as 8x squared minus 60x minus 3x plus 10. So remember, this is what we call the AC method. Product of two numbers, it's AC that adds to B. Then we factor by grouping, which you can take a 6 and an x out of these two, leave us with 3x minus 10. Taking a negative from those, and you're left with 3x minus 10. And so that gives us 6x minus 1 times 3x minus 10. All right, let's go back. 11x squared minus 144, there has a GCF of 11 in there. And there's your difference of squares, x minus 2 and x plus 2. Five x squared plus 20, they both have a 5 on them, so I can factor that out. Leaves me with x squared plus 4. X squared plus 4 is a sum of two squares, and that's always irreducible. Okay, 27x cubed minus 64. That matches this formula. So we use the difference of cubes formula. So we have to take and find these pieces first. 27 is the cube of 3. X cubed is the cube of x. 64 is the cube of 4. So it says we recover our two pieces, a minus b, 3x minus 4. And then it says to square the a. 3x squared tells us to take the product of a and b, which is 3x times 4, and then plus b squared, which is 4 squared. So then you just have to multiply these out. 3x squared is 9x squared. 3x times 4 is 12x plus 16. Number 46, common factor of x. Pulling it out, we get x squared plus 4x minus 60. That's the product of two numbers. It's negative 60 that adds to 4. Looking at an x plus 10 and an x minus 6. 3x to the fourth minus 48. Take out the 3 and we're left with x to the fourth minus 16. X to the fourth minus 16 is x squared minus 4 and x squared plus 4. But x squared minus 4 is x minus 2 and x plus 2. .48, we've got 4 terms there. So we look to factor by grouping. Taking an x squared off the first pair, we're left with 2x plus 3. Taking off a negative 4 from the second pair, we're left with 2x plus 3. Taking off a 2x plus 3 to the right-hand side, we're left with x squared minus 4. That's a difference of 2 squares, x minus 2 and x plus 2. Number 49, they all have zeros on them, so that means you can take out a 10. So we have a 2x and an x, and we need it to get negative 7 in the middle. So negative 3 there would give us negative 6. Minus 1 would be the negative 7. All right, number 50. I tend to go back to the AC method when the numbers aren't prime, I should say, because 2 and 3 were prime in the one before it. So we're looking at 18 to get 11, and we've got 9 and 2. From the first pair, I can take out a 3x, which leaves me with 2x plus 3. From the second pair, I just get 2x plus 3. So we factored off to the right-hand side, and we're left with 3x plus 1. Number 51. I don't like negatives in front, so I take them out, as well as the 2 that's in common with all of them. Changes the sign now, negative x and minus 1. All right, 6x squared. It's got to be a 2x. Well, it doesn't have to be, but I'm going to try this. 2x and a 3x. Now we need to get negative 1, so we have 1 and 1, but we need to add to get negative 1 in the middle. So if I use positive 2x and minus 3x, that'll do it for us. Okay, so now we're getting into those problems where I told you that some of these would just not be asked on the final. And here's one of them. This is one I'm not going to ask you on the final. Here's another one. A few more up here. 56. $65. believe that one's good. You can strike out 72, 73. Okay, I think that's it. All right, 2p to the fourth plus 250p. We take out a 2 and a p. Leaves us with p cubed plus 125. That's the sum of cubes formula. A cubed plus b cubed is a plus b times a squared minus ab plus b squared. So here our pieces are p and 5. So we add them, p plus 5, and then we square product and square the 5, which is 25, but opposite and always positive. $57, everything's divisible by 2 in there, so we take out the 2, we're left with m squared minus 8m plus 16. That's the product of two numbers at 16 that adds to negative 8, and we've got m minus 4 and m minus 4. Doesn't look like there's anything I can factor out of those two, so let's use the AC method on this one. We got 60 to get to 61. 60 and 1 are the numbers. So we've got 6x squared plus 60xy plus xy plus 10y squared. From the first pair, I factor out a 6x. Leaves us with x plus 10y. From the second pair, I factor out a y, and I'm left with x plus 10y. Factoring off the x plus 10y to the right-hand side, I'm left with 6x plus y. 59, x squared plus 6x plus 9. We've got x plus 3 and x plus 3. $60 is a sum of two cubes. Two pieces that we're cubing are m and 3. Formula, we add them, then we square them. Product and square. And you always use the same and then opposite sign and always positive. Again, the formula will be given to you. $49x squared minus 36y squared, that's a difference of squares. 7x minus 6y and 7x plus 6y. 27p cubed minus 8, that's the difference of cubes. We're looking at the two terms of 3p and 2. So we recover them and we use the same sign. And then we square the 3p, which is 3p squared is 9p squared. Take the product of 3p and 2, that's 6p. And we square the 2, and that's 4. So we use same sign, opposite, and always positive. X squared plus 25 is the sum of two squares. That's always going to be prime. Can't factor sum of two squares. But x to the fourth minus 81 is a difference of squares. Square of x squared, so that's x squared minus 9 and x squared plus 9. X squared minus 9 is x minus 3 and x plus 3. $66. We can take out a a 4, and x squared, and a y. Leaves us with 2x squared minus 3x y minus 5y squared. That trinomial there has to be an x and a 2x to start, or 2x and x. And then I can use 1 and 5 or 5 and 2. I need to put y's on them though. So if that's 1y, that would be a 2xy and a 5xy. We need that to be negative to get negative 3, and that to be positive. $67, whenever you have 4 terms, we factor by grouping. We're going to take the a out, we'll be left with x plus 2y. Take out the negative 7, and we'll be left with x plus 2y. Now we see that one of the factors is a minus 7, and the other one is x plus 2y. Number 68, the 81x squared is a perfect square. The 25 is a perfect square. So I believe this should be 9x minus 5 and 9x minus 5. And so there's negative 45 and negative 45, which gives negative 90. So we would want to write this as 9x minus 5 squared. Let's see, 69. We have the 2 that can come out of there. That's x to the 4th minus 16y to the 4th. So that's a difference of squares. That's x squared and 4y squared and 4y squared. Add them and subtract them. X squared plus 4y squared is a sum of 2 squares. That's prime. But x squared minus 4y squared is x minus 2y times x plus 2y. Number 70. This is not prime because I can take out a 4, but then what remains is prime because it's a sum of 2 squares. 71, we see all 3 terms here have an x plus 5y on them. So we factor it off to the right-hand side, just like we did with grouping. And then what we're left over with is a squared plus 2ab plus b squared. Now, a squared plus 2ab plus b squared is a plus b times a plus b. $74, we factor out a 2p from those 2 terms, and we're left with p cubed plus 125. Sum of 2 cubes again. The 2 terms are p and 5. So we recover them and use the same sign, and then we square the p and take the product of the 5 and the p and square the 5, which is 25. Same sign, opposite sign, and always positive. $75, we have 4 terms. We factor that one by grouping. Take out the x cubed from the first pair. We'll be left with x minus 1. Factor a negative 1 from the second pair. We'll be left with x minus 1. So look at what we have now. We factor the x minus 1 to the right, and we're left with x cubed minus 1. But the x cubed minus 1 is a difference of cubes. So we recover our 2 pieces, x and 1, and then we square product, square the 1 is 1. We use opposite signs there and always positive. So really what we have there is x minus 1 squared times x squared plus x plus 1. 76, x squared plus xy plus y squared. That's the product of two numbers that's 1 that adds to 1. It's not going to happen. That's prime. 77, those are big numbers. We must be able to take something out of here. Looks like a 4. I might be wrong. Maybe take something bigger, but we'll check it in just a second. Take out the 4a. We're left with 16x squared minus 26x plus 10. And now I see I was really supposed to take out 8. Because these are all even. So that leaves me with 8x squared minus 13x plus 5. All right, so we get 8a. Well, I'm thinking I'm going to factor that one by grouping. 8x squared minus 13x plus 5. That's 40 to get negative 13. So we would use negative 8 and negative 5. Take out the 8x, and I'm left with x minus 1. Take out the negative 5, and I'm left with x minus 1. This is 8x minus 5 and x minus 1. All right, 2 more. I don't like leading coefficients that are negative, so I take them out when I can. There is no other GCF, but change the signs. Now we got a perfect square there and a perfect square there. Worth a try, 3x and 5y. 3x and 5y. And that middle term is 30. And this is correct because we have negative 15xy and negative 15xy, which is negative 30xy. Now you're also welcome to rewrite it as the opposite of 3x minus 5y squared. And the last one, we've got 4 terms. So we factor by grouping. Take out a 27x cubed will leave us with x squared minus 1. Take out a negative 8y cubed, we'll be left with x squared minus 1. So we have 27x cubed minus 8y cubed and x squared minus 1. So both of those can be taken further. This is the difference of 2 cubes, the cube of 3x, and this is the cube of 2y. So we recover our 2 pieces, 3x and 2y, and we use the same sign. Then we square the 3x, which is 9x squared, take the product of 3x and 2y, which is 6xy, and square the 2y, which is 4y squared. We use opposite sign and always positive. But then we have the x squared minus 1, which is x minus 1 times x plus 1. All right, so that's the conclusion of the first part of this, and we'll finish the rest of this tomorrow night.